take too long to start on Earth? Did it start on Mars? That's roughly the question. Now, when planets form, there's a lot of raw materials that go along with that. A lot of that is carbon chemistry. You can see here from primitive meteorites. We know that a lot of carbon chemistry, in some cases very complex carbon chemistry, can form in the conditions that form the planet initially. So we know that this material is ubiquitous and widespread during the formation of planets. So Earth and Mars got an inventory of this material. We started to find life way back on Earth, on Mars. Actually, on Earth we find places where organic chemistry is still ongoing. So if you think about it, most life is made up of carbon-carbon bonds. We're very, very complex bits of carbon chemistry. But carbon chemistry can be done in many other places and in many other ways. That carbon chemistry can be very simple. Formation of amino acids, Stanley Urey-Miller experiments in the 50s showed that you could make quite complex carbon chemistry from just simple gases and electrical discharge. On Earth we have these places like deep sea hydrothermal vents that are spewing forth hot water and across metals, which we know are catalysts, producing organic chemistry. And in those environments there's a huge amount of life taking advantage of the organic chemistry and simple chemistry done in those environments to actually forge a living. Here you can see all the worms at the bottom of the red here, all these kind of tube worms at the bottom of the hydrothermal vent and right down at the base of the ocean on Earth. Those were actually discovered the same year that the Viking landers went to Mars. We know a lot more about them than we do about Mars. Where I came into this story is I went to work for a gentleman called Dave McKay at Johnson Space Center in 1996 who thought he found relic evidence of life on Mars. And that created a huge debate at the time as to what, whether or not there was life on Mars, whether or not he found evidence of life on Mars, and how we would find life on Mars. And here you can see one of the fossil type that he postulated was evidence of life on Mars. I came into it as a microbiologist and started looking at the rock and realised there was a great deal of terrestrial contamination of organisms that we Dave's with Dr. Case had at the time. So all of the instruments that were thrown at the meteorites at that particular time to try and prove life on Mars said there was, mostly said there was no life. There was terrestrial. So obviously there was a bit of a disconnect between what we wanted to find, how we wanted to find it, and what we could use to find it. This is an image of another Martian meteorite called Napla, and in this meteorite we find terrestrial organisms growing all the way through. I put this up to be deliberately provocative because, as you can see from this, the small black line at the bottom here is 1 micron. Now that's the normal size of a bacterial cell on Earth, roughly speaking. The rest of it is tiny. Those branches are extremely small. Terrestrial life, as we know it, is not hammered down. We don't know much about the vast majority of microbes on this planet. We can only culture 2% to 3% of the organisms on this planet. We know that due to the genetic fingerprint. There are many things that we don't know about life on our own planet.